Hi guys, so what we're doing today, we are looking at decay equations. A lot of people get a bit confused by this because they mix it up with balancing equations. What we do in chemistry, much simpler than that. So first thing we're going to do is we're going to have a quick recap on different types of radiation and their properties. Then we're going to look at how you can make these decay equations. So first off, we've got some different types of radiation, all coming from the nucleus of an atom. So to start off with, top one, we have alpha, then beta, gamma, and neutron. So alpha, 2 neutrons, 2 protons. Beta, which is a fast, really important you say that, electron. Gamma, which is an electromagnetic wave. And the neutron, well, it's just a neutron. All of these come from the nucleus, and when something emits a type of radiation, it can make that nucleus change, it makes the atom change into a different element. So this is what a decay equation shows. So we look at some notation that we did about before. This here is the atomic number, which is the number of protons. This at the top, that is your atomic mass. Remember, mass is the massive number. This here is the number of nucleons. And by that we mean the number of protons and the number of neutrons in a nucleus, the number of particles in a nucleus. So if you had something like helium, you've got 2 protons. You could even say you've also got 2 electrons because they're the same number. The charge of an atom has to be 0. And this here is the number of nucleons, the number of particles in a nucleus. Well, if you've already got 2 protons, you can immediately say, well, 4 minus 2, you've got 2 neutrons. And this is a symbol. In physics, we're not too worried about some of the symbols. The main thing is you need to know are the symbols for alpha, beta, gamma radiation. You don't need to remember anything about any elements, what their symbols are. The only one you do need to remember is possibly helium, because sometimes they say this instead of alpha. So if we go on for this, for example, so let's say we've got a nucleus over here. This nucleus is uranium. If you look here, we've got 92 protons and we've got a nuclear number of 238. So that is the total number of neutrons and protons. And what happens is that this will decay, and when it decays, the nucleus will change, because literally the nucleus is losing this big chunk here. So it's going to have 2 fewer neutrons and protons. So what we say is beforehand we call it the mother nucleus, and afterwards we call it the daughter nucleus. Isn't that sweet? So what we need to do is this. We need to look at what it's going to be like afterwards, and we also need to name what this is. So this is alpha, which is essentially a helium nucleus. So you could write it as helium. You could use the alpha symbol like here. Just depends what they've got as well, because they might have one or the other. We know that is 2 and that is 4. So if you have a nucleus that originally had 92 protons and it's given out a helium nucleus, i.e. alpha particle, it's going to have 2 fewer protons, so it's now going to be 90. So if you've given out 2 protons and 2 neutrons as well, then this number here is going to be 4 less 2, 3, 4. And you can see, if you like, they add up. You've got 90 and 2 here, 90 and 2, 92, 2, 3, 4 and 4 there, 2, 3, 8. You do not need to know any symbols. As I said, you don't need to think, oh, what does that turn into? I don't know the symbol for that. Don't worry. They will normally tell you that. That one happens to be thorium. What a cool name. Right, beta radiation. Beta is a bit weird. I've always had people saying, well, where does this electron come from? My old physics teacher said, oh, it's just one that's hidden in the nucleus. Some people think this electron is one from the shell. It's not. What happens is, to make a nucleus more stable, it has to get rid of some of the neutrons and get more protons. So what happens is a neutron changes into a proton and an electron. This can happen. When you get to A level, you learn about conservation rules. As long as some things are the same before as afterwards, it's absolutely fine. A good example of this is charge. Neutron charge, 0. Proton charge, +1. Electron, -1. Total charge before, 0. Total charge afterwards, 0. So what that proton will do is that proton will replace the neutron, and then the electron gets fired out. It usually has quite a lot of kinetic energy, hence why it's fast. So let's say we've got this, carbon-14. Not your normal carbon, because it's got 2 more neutrons. So what you can do is you can work it out using this, if you like, using the fact that a neutron changed to a proton. So what's going to happen is you're going to gain another proton. So that number is now going to be 7. Now, the total number of particles in the nucleus, if one neutron's changed to a proton, even though you're losing a neutron, you're gaining a proton. So that number will remain exactly the same. So that there will be your new element, and that happens to be nitrogen. Again, you don't need to know that's nitrogen. They will have it for you. So then what you've got to do is you've got to account for beta. So what we do is we either call that an electron, or usually they give it the beta symbol. If you do want a symbol for electron, they might call it E. So what you've got to do is just make sure these numbers all match up. So if you've got 7 here, and that's 6, that has to be -1. 7 minus 1 equals 6. This one, 14 here, 14 afterwards. This one, 0. It's a good way just to check all your numbers are okay. Does that plus that equal that? Same for the bottom bits. Gamma. If something goes through gamma, gamma is not a particle. You could argue it's a photon, but in terms of GCSE physics, it's not a proton, not a neutron. It's just a change in energy levels. So what happens is that if something decays by gamma, nothing. Nothing at all. Right, neutron. Now, I've never seen a question on this, but they could ask you it. Just want to see if you guys can think what's going to happen. If something goes through neutron decay, it's going to lose a neutron. So this number here will stay exactly the same. This top number will therefore change. Now, because your number of protons, your atomic number stays exactly the same, your element should be the same. Now, if you want to know what's going to happen over here, if something does go through neutron decay, it's going to go out neutron. Neutron will be an N. This number here will be a 1, and that will be a 0, because a neutron is something that makes up a nucleus, but it's not a proton. So if something does go out neutron, it shouldn't change what element it is at all. All it will do is it will remove a neutron and become an isotope. Here are some examples. Have a pause, see if you can work out what happens next. Okay, here we go. There are your answers. As I said, you're not supposed to know that's radium there. It will be given to you. If you want some more examples, this is on your task. And here are your answers. Goodbye.